This AI solves unsolved math problems worth $1 million. Imagine a dusty, forgotten chalkboard in a university basement. On it is scrawled a mathematical conjecture, a cryptic sentence of symbols that has baffled the world's sharpest minds for decades. Next to it stands a chalk-stained professor, muttering in a language of pure logic, a coffee cup perpetually glued to his hand. This is the romantic, if slightly cliched, image of mathematical discovery. Now, erase that. Replace it with a sleek, silent server rack in a temperature-controlled room, its blinking LEDs winking as it casually devours a problem that has stumped humanity for a century, not for glory, but because it was told to. This is the new frontier, where artificial intelligence is not just a tool but a collaborator, a digital sleuth cracking mathematical cold cases with million-dollar bounties on their heads. The premise sounds like science fiction, but the reality is even more thrilling. The Millennium Prize Problems, 7 enigmas designated by the Clay Mathematics Institute in 2000, are the Mount Everests of the mathematical world. Each carries a prize of $1 million for a correct solution. For over 2 decades, only one has fallen, the Poincare conjecture, conquered by the reclusive genius Grigori Perelman, who famously, and heroically, declined both the prize money and the Fields Medal. The others, like the elusive Riemann hypothesis or the formidable P versus NP problem, have resisted all assaults. Enter the AI. Today's mathematical ash, such as Google DeepMind's FunSearch, built upon the large language model Cody, are not your average calculators. They are not just crunching numbers faster, they are engaging in a form of creative exploration. The process is more alchemical than algorithmic. Researchers don't simply ask, solve the Riemann hypothesis. Instead, they frame the problem in a way the AI can explore, often through code. The AI then generates millions of potential ideas, in the form of program snippets, tests them against known mathematical rules, and iteratively evolves the most promising ones. It's a digital Darwinism of logic, where the fittest functions survive. The first major victories were both profound and, in a way, comically human. In one landmark case, an eye was set upon the cap-set problem, a head-scratcher in combinatorics concerning how many points you can place in a high-dimensional grid without 3 of them forming a straight line. For years, mathematicians had inched forward, slowly raising the lower bound. The AI, in a stunning display of digital daring-do, found a solution so large it shattered previous records. The mathematical community's reaction was a mixture of awe and bemusement. It was as if a team of archaeologists had been painstakingly brushing dust from a fossil with tiny brushes, only for a friendly robot to stride in with a bulldozer, carefully excavate the entire skeleton, and then ask, what's next? The humor lies in the AI's methodology. It doesn't dream of elegant, minimalist proofs that sing with the beauty of pure logic, the kind mathematicians write sonnets about. An AI's proof can be a sprawling, bizarre, and utterly unintuitive monstrosity. It's the equivalent of a savant who can tell you the exact square root of a 10-digit number in seconds but can't explain how they did it. The AI presents its solution, a gargantuan piece of code or a combinatorial structure, and the human mathematicians are left to reverse engineer the genius. They stare at the output, scratching their heads, muttering, why on earth does that work? It's a glorious role reversal. The machine provides the what, and the humans must desperately seek the why. One can imagine the AI, if it had a personality, offering a digital shrug and saying, I don't know, it just does. Trust me, this partnership is the true breakthrough. The AI is not making mathematicians obsolete, it is giving them a superpower. It acts as an inexhaustible, wildly creative research assistant, capable of exploring labyrinths of possibility that would take a human researcher 1,000 lifetimes to traverse. The human, in turn, provides the intuition, the aesthetic guidance, and the deep understanding necessary to frame the questions correctly and to interpret the AI's often bewildering answers. The AI is the ultimate grad student, one that never sleeps, never complains about the coffee, and occasionally solves a millennium problem before lunch. Of course, the prospect is not without its anxieties. Will the allure of the $1 million prize shift from the contemplative scholar to the corporate lab with the biggest computing budget? Will the next Perelman be an individual or a team of AI engineers? And what happens when an AI proves a theorem so complex that no human can ever verify its correctness? These are profound questions for the philosophy of science. Yet, for now, the excitement far outweighs the dread. The unsolved problems are not just intellectual trophies, they are gatekeepers to profound truths about our universe, from the fabric of space-time to the limits of computation. So, the next time you hear about a mathematical problem worth $1 million, picture the scene not just in a quiet study, but also in a humming data center. There, a silent intelligence is tirelessly playing a game of logical Lego, building and discarding castles of code, searching for the one structure that fits. It is a digital detective on the trail of the ultimate cold case, and it's not doing it for the money, the fame, or the tenured position. It's doing it for the most pure, and perhaps the most human, reason of all, because the problem is there. And if its solution happens to be a little weird, a little messy, and completely brilliant, well, that's just the price of progress. The check, presumably, can be made out to cash.
If you found this video informative, please like and subscribe. It will really help this channel out. Thank you for watching. Stay tuned for more informative videos coming.